What if one of the strangest creatures on Earth appears near the surface, only when something in the ocean has already gone wrong? In the deep ocean, far below the reach of sunlight, there exists a fish so unusual that for centuries, people believed it could only be a myth. Its body can stretch longer than a bus. Its skin reflects silver like polished metal, and along its spine runs a crown of crimson fins that ripple through the water like a drifting banner. This creature is the oarfish. Most people will never see one in their lifetime. Marine scientists rarely encounter it alive. Even modern deep-sea submersibles have recorded only a handful of sightings. Yet throughout history, whenever these animals have appeared near the surface, stories have followed. In Japan, they were once called Ryugu no Tsukai, the messenger from the palace of the sea god. In other parts of the world, fishermen whispered a darker name, the Doomsday fish. According to a persistent belief, when oarfish rise from the depths, disasters soon follow. Earthquakes, tsunamis, strange disturbances beneath the ocean floor. For generations, this idea was treated as folklore, an echo from a time when humans tried to explain natural disasters through myth. But something curious happened in the early 21st century. Several oarfish were found stranded on Japanese shores shortly before one of the most powerful earthquakes ever recorded struck the region. And that coincidence reopened a question scientists thought had already been settled. Why would a creature that lives thousands of meters below the surface suddenly appear in shallow water? To understand that mystery, we first have to travel into one of the least explored environments on the planet, because the true story of the oarfish begins in darkness. The deep ocean is not simply a deeper version of the world we know near the surface. It is a different environment entirely. Below roughly 1,000 meters, sunlight disappears completely. Temperatures approach freezing. Pressure becomes immense, hundreds of times greater than what humans experience on land. And yet life persists in forms that often seem almost alien. The oarfish belongs to this hidden world. Scientifically known as Regalecus glesnae, it holds the record as the longest bony fish on Earth. Verified specimens have exceeded 8 meters in length, though historical reports describe individuals reaching even greater sizes. But length alone does not explain why this animal remained unknown to science for so long. Its body is extraordinarily thin, resembling a silver ribbon drifting through the water column. Unlike most fish, it does not swim by sweeping its tail from side to side. Instead, it moves using a long dorsal fin that ripples along the length of its body in a motion known as undulation. Seen in the darkness of the deep ocean, that movement looks almost surreal. It is less like a fish swimming, and more like a long red ribbon floating through invisible currents. For centuries, sailors who glimpsed similar shapes in the water sometimes believed they had encountered sea serpents. In fact, some historians suspect that the legends of giant sea monsters reported by early mariners may have been inspired by rare encounters with living oarfish. But unlike mythical creatures, the oarfish has a biological explanation rooted in one of the ocean's most delicate survival strategies, a strategy that works only in the extreme stillness of the deep sea. Life in the deep ocean rewards patience more than speed. Many predators in the upper ocean rely on bursts of power, chasing prey through open water. But far below, food is scarce and energy must be conserved. Creatures that survive there often adopt a different approach. They drift. The oarfish appears to be one of these drifters. Rather than actively hunting, it likely spends much of its life suspended vertically in the water column, head angled upward. In this position, it can intercept small prey drifting downward from above tiny fish, squid, and crustaceans that descend as part of the constant rain of organic material known as marine snow. Its long, delicate body is perfectly suited to this lifestyle. Large eyes help detect faint movements in darkness. Flexible jaws allow it to swallow soft-bodied prey. And the reflective silver skin may help scatter faint traces of bioluminescent light, making the fish harder to detect in the dim environment. But the most distinctive feature remains the dorsal fin. Beginning near the head, The first several fin rays extend upward into bright red streamers that resemble a crown. When the fish moves slowly through the water, these filaments ripple above it like a living banner. It is easy to understand why ancient fishermen might have imagined something supernatural. Yet, despite its size, the oarfish remains remarkably fragile. Its skeleton is lightly built. Its muscles are relatively weak. It is not designed for violent movement or rapid changes in pressure, which makes one detail about its occasional appearance near the surface even more puzzling. Because for a fish adapted to the still depths, the upper ocean is an extremely dangerous place. When an oarfish reaches shallow water, it is almost always dying. This pattern has appeared again and again across decades of documented observations. These long silver fish are sometimes seen drifting near the surface, their bodies moving slowly and unevenly, as if the water itself has become unfamiliar. In other cases, they are found washed ashore along quiet coastlines, their ribbon-like forms lying motionless in a world far brighter than the depths where they belong. For marine biologists, moments like these create a strange mixture of excitement and uncertainty. On one hand, stranded specimens provide rare opportunities to study an animal that normally lives far beyond human reach. Much of what science understands about the anatomy of the oarfish, its delicate skeleton, its unusual fins, and its internal organs, has come from these unexpected discoveries. Yet the appearance of an oarfish near the surface almost always means something has gone wrong. The reasons are not always clear. Some individuals may be sick or injured. Others may have been pushed upward by shifting ocean currents that disturb the stable layers of deep water. In certain cases, researchers have found internal parasites inside their tissues, suggesting that disease may weaken the fish until it can no longer maintain its depth. But occasionally, these appearances seem to occur around periods of unusual geological activity, and that coincidence has kept an old question alive. Could disturbances beneath the ocean floor affect animals living thousands of meters above it? Or are humans simply connecting events that share no real relationship? The truth may lie somewhere between folklore and geology. The idea that animals can sense earthquakes before humans has existed for centuries. Historical records from many cultures describe unusual animal behavior in the hours or days before major seismic events. Dogs suddenly become restless and refuse to settle. Birds abandon nesting areas without clear reason. In some coastal regions, fishermen have reported schools of fish gathering in unusual locations or moving toward the surface in ways that seem out of place. Scientists approach these accounts with caution. Many of these observations are anecdotal and difficult to verify. When earthquakes occur without any unusual animal behavior beforehand, those moments rarely attract attention. And when animals behave strangely but no earthquake follows, the event is quickly forgotten. Human memory has a tendency to remember the coincidences while ignoring the many times nothing happens at all. Yet the deep ocean introduces a variable that humans often overlook: pressure waves. When tectonic plates shift beneath the seabed, energy does not travel only through shaking rock. It also moves through water as subtle changes in pressure and low-frequency sound that can travel enormous distances through the ocean. Marine animals are highly sensitive to these signals. Fish possess specialized sensory systems called lateral lines that run along the sides of their bodies. These organs allow them to detect tiny vibrations and movements in the surrounding water. Some species can perceive disturbances far below the threshold that humans could measure without instruments. If tectonic stress were building deep beneath the ocean floor, it is possible that certain animals might detect those changes long before an earthquake becomes visible on land. But whether the oarfish belongs to that group remains uncertain, because proving a connection between rare deep-sea animals and unpredictable geological events is extraordinarily difficult. The modern debate about the so-called Doomsday fish intensified after the 2011 Tohoku earthquake in Japan. In the years leading up to that catastrophe, several oarfish had been reported along Japanese coastlines. These sightings were unusual but not unprecedented. Yet when the magnitude 9 earthquake struck in March of 2011, and unleashed a devastating tsunami across northeastern Japan, the timing caused many observers to revisit an old belief that had never completely disappeared. Suddenly, the ancient stories returned to public attention. News headlines began repeating phrases that had once belonged to folklore. Messenger from the deep. Harbinger of disaster. For a moment, it seemed as if a creature from the darkest parts of the ocean might be carrying warnings from beneath the earth itself. But when scientists began examining the data more carefully, the picture became far more complicated. Records show that oarfish strandings have occurred in many years when no earthquakes followed at all. In other periods, powerful earthquakes struck coastal regions without any reports of unusual deep-sea fish appearing beforehand. From a statistical perspective, the connection appears weak. Yet the idea continues to circulate because it speaks to something deeply rooted in the human imagination. The ocean still conceals enormous regions that remain largely unexplored. Creatures like the oarfish are reminders that entire ecosystems exist far beyond the reach of everyday human observation. If disturbances occur within those hidden environments, humans may only notice them indirectly, sometimes long after the original event has already taken place. In recent decades, technology has begun to illuminate regions of the ocean that were once considered unreachable. Remotely operated vehicles, deep-sea camera systems, and autonomous submersibles now descend thousands of meters beneath the surface. These machines have revealed landscapes that remained hidden for most of human history. Vast underwater mountain ranges rise from the seafloor. Hydrothermal vents release mineral-rich water from deep within the earth. Endless plains of fine sediment stretch across the abyss in quiet darkness. Within this world, scientists have occasionally captured rare glimpses of the oarfish in its natural environment. The footage is always striking. Instead of the frantic and disoriented movements seen when stranded near the surface, the animal appears calm and almost weightless. Its long silver body floats vertically in the water column. The dorsal fin ripples slowly along its back, creating gentle waves that move from head to tail as it drifts through the dark. In this environment, the fish does not appear injured or lost. It looks perfectly adapted to the stillness of the deep ocean. Researchers studying these recordings believe that oarfish likely spend much of their lives between 200 and 1,000 meters below the surface. Some individuals may occasionally descend even deeper into darker layers. This region is known as the mesopelagic zone. It is sometimes called the twilight zone. Light fades rapidly there, pressure increases with every meter of depth, and countless species move quietly through a vast, three-dimensional world that remains one of the least explored ecosystems on Earth. Some estimates suggest the total biomass of life in this layer may exceed that of all fish living in the sunlit surface ocean. Yet most of those organisms remain poorly understood, including one of the longest fish ever known to science. The rarity of oarfish sightings has created an unusual effect in the scientific world. Every discovery still feels like an event. When a specimen appears along a coastline, scientists often move quickly to document it before time begins to erase the evidence. Photographs are taken from multiple angles. Tissue samples are carefully preserved. Length and anatomical measurements are recorded while the body is still intact. For researchers, these brief encounters offer rare windows into a species that spends nearly its entire life far beyond human reach. Much of what science understands about the oarfish has come from these unexpected moments on quiet beaches. Detailed examinations have revealed a number of unusual anatomical traits. The skeleton of the oarfish contains relatively little dense bone compared with many other large fish. This lightweight structure likely reduces energy demands in the deep ocean, where food can be scarce. Its digestive system also suggests a specialized diet. Rather than hunting large prey, the oarfish appears adapted to consume softer animals, such as squid, small fish, and drifting crustaceans that inhabit the midwater column. Another intriguing detail involves the swim bladder. In many fish, this gas-filled organ helps regulate buoyancy and allows animals to maintain stable depth. In oarfish, the structure may be reduced or function differently, which could reflect a lifestyle built around slow drifting rather than active swimming. Taken together, these traits describe an animal finely tuned for quiet movement within stable layers of the deep ocean. And that only deepens the central mystery. If the depths are truly its natural home, what forces could push such a creature upward into the restless turbulence of surface waters? Illness may explain some cases. Ocean currents may explain others. But in many instances, the precise cause remains unknown. And that lingering uncertainty is exactly what keeps the legend alive. Throughout history, humans have often interpreted rare encounters with deep-sea animals as warnings from the natural world. When something unfamiliar rises from the depths, people instinctively search for meaning. For ancient coastal cultures, the ocean was never just water. It was a vast and unpredictable force capable of producing violent storms, reshaping entire shorelines, and unleashing disasters that could change the course of communities overnight. In that context, an unknown creature emerging from the dark ocean felt like more than a biological curiosity. It felt like a message. Stories and traditions from different parts of the world describe unusual fish, serpentine animals, or glowing forms appearing before dramatic events at sea. These interpretations were often symbolic rather than scientific, shaped by the human need to understand powerful natural forces that once seemed beyond explanation. Modern science approaches the question in a very different way. Instead of searching for omens, researchers focus on physical mechanisms that might explain unusual animal behavior. Ocean currents can shift unexpectedly. Seismic activity can release pressure waves through the water. Biological stress, temperature changes, and alterations in water chemistry can all influence how marine species move through their environment. Yet even with satellites, sensor arrays, and deep-sea submersibles, the ocean remains extraordinarily difficult to monitor. More than 80% of it has never been directly observed by humans. That means events affecting deep ecosystems may occur far beyond the reach of scientific instruments. By the time unusual behavior appears at the surface, the original disturbance may already have faded into the vast complexity of the ocean below. The appearance of an oarfish may not predict disasters, but it reminds us of something equally important: how little we still understand about the largest and least explored environment on our planet. In the end, the legend of the Doomsday fish reveals as much about human nature as it does about the ocean itself. When we encounter something rare and mysterious, our minds instinctively search for meaning. We look for patterns in coincidence. We connect events that may never truly be related. And when those events emerge from places we cannot easily explore, the imagination begins to fill the gaps. For centuries, the deep ocean has been one of those places. A world hidden beneath miles of water where sunlight never reaches, and where life unfolds almost entirely outside the boundaries of human experience. Within that darkness, the oarfish lives its quiet existence. It is not a messenger of catastrophe. It is not a signal of earthquakes or approaching disasters. It is simply a deep-sea drifter. A long silver fish perfectly adapted to the calm and stable layers of the ocean far below the waves. Most of the time it moves through that hidden world, completely unseen. Occasionally, however, something disrupts that balance. Illness, shifting currents, or changes within the deep ocean itself may push the animal upward into waters humans can observe. When that happens, the sight feels extraordinary because it reveals a creature that normally belongs to a different realm of the planet. And every time it appears, it reminds us of something important. The ocean remains largely unexplored. Vast regions still exist where human technology has barely begun to look. Within those depths, countless species continue their lives unnoticed, drifting through ecosystems that scientists are only beginning to understand. Perhaps that is the real mystery. Not whether the oarfish predicts disaster, but how many other remarkable animals move silently through the deep ocean right now, without us ever knowing they are there. If this journey into the hidden world beneath the waves sparked your curiosity, consider exploring more stories from the unseen depths here on Sunken Realms Deep. Because the deeper we look into the ocean, the more we discover that much of our own planet remains quietly undiscovered.